Fozia. It's a pleasure. Hello, everyone. Assalamu alaikum. My name is Roshan. I currently serve as the science communicator for the Office of the Dean, School of Science and Engineering. And it's a pleasure being here in Dr. Fozia's class. I intend to make some notes on the class, on the whole course. Thank you so much, Dr. Fozia, for this opportunity. Thank you.
Not at all. Thank you for coming. And maybe you can tell us some things. Maybe you can give me tips on being a bad or good communicator in the class. But yeah, thank you for joining us. And I hope the students are happy that we are now going to become a story somewhere in the SSC history. Okay.
It's a pleasure. Thank you.
Thank you, Roshan. So Nadia, back to your question. So we said that eutrophication happens in lakes where there are phosphates and nitrates, so excess nutrients. Now that lake is situated inside LUMS, which means that maybe nitrates and phosphates in the form of fertilizers are coming from the LUMS lawns to that lake or that small pond that is there. Now, one thing is obvious, that there is excess nutrients in that pond. All right. And that means that we either need to make sure that we are putting enough fertilizers in the lawns and that it's not excess and it's not washed and the water that's coming out of the lawns does not become wastewater. That it becomes, it's not an agriculture wastewater or a gardening wastewater. It's a water that has lesser nutrients. Now, let's say we have done that. We have increased the nutrients and the lake has now become eutrophic. Then what do we do, right? So the first way would be to let the algae grow and let it grow and take up the nutrients. The other would be to apply some form of chemical treatments, which of course the chemistry people know better about coagulation, flocculation, where you put in some chemicals and make sure you remove the phosphates, right? So all of those interventions can take place. The best thing generally for smell is, and why does smelling happen? Remember I said that when algae grows on top, then the air below it or the water, the hydrosphere below it becomes anoxic. There's no light, and because of no light, the photosynthesis that's taking place inside or the oxygen diffusion that's taking place in that water body doesn't take place, and suddenly it becomes that dead zone that it was in an otherwise very at the bottom of the pond, right? So now it's become an atmosphere or a hydrosphere where there's less oxygen, and that's why it starts stinking and light doesn't go through, which means life in general doesn't thrive, and that oxygen carbon dioxide exchange with the atmosphere doesn't happen. So a lot of those things. So perhaps you could ask your administration to make sure that whatever's growing there is removed, and then there's aeration, at least to avoid the smell. Or otherwise, if your role is to see how much phosphates are in there, you can simply just get it analyzed from the chemistry department and look for suggestions on how to improve it. Does that answer a little bit of your query?
Yes, ma'am. Thank you so much. But ma'am, I wonder why don't we just get rid of that pond? Because, or I mean, I know that the first thing is just to clean or put some chemicals and just clean it up. But if they are not willing to do so, then why don't we just get rid of it? Well, because a lot of work is done in the courts and tennis courts, but nothing is done near our hostels, which is very disturbing.
Yeah, if I haven't taught you to speak up for the rights of course, human environment in general and natural environment in particular, then I haven't taught you anything. So maybe you guys, all of you students who are in the hostels right now can write about this. And to my knowledge, I think something's going to be constructed there. I personally am very fond of green spaces and spaces that contain water and spaces that contain life. So if you ask me, I would expect for it to remain there and expect for it to be clean. But I think in general, because if it hasn't been maintained in that many years, then I am also aware of the fact that there's going to be a building there soon. But if you want to change it, then you definitely write the concerned authorities about it. Right.
Right. And what about the Nala outside the hostel? I mean, that's a concern of all of us, right?
Yeah, the Nala is, that's again such a huge debate. Like, where do we start? And I think I had this discussion with you before where I said it has so many people and so many stakeholders there. And I don't know exactly where your hostel is situated, but let's say it's situated close to the Nala, then even there, just to avoid the smell, perhaps like a more oxygenated environment could be provided for the bacteria to grow and to, you know, sort of get rid of the smell, or provide enough oxygen for them to breathe in an oxic condition environment. But that wouldn't necessarily mean that a lot of gases and toxins are taken care of, because life there can only take care of certain things. So there's a lot that needs to be done there. So whatever discussion we've had on that before, I think that needs to continue. And we have been trying to, you know, put some sort of proposal, some kind of intervention in that, but we haven't, because for any research you need money, and then to solve this particular problem, you need not only need money, but you also need a lot of other people to come on board and do something together. And I think it's not as easy a task as we think. But hopefully at some point we look at the basics of wastewater treatment. We did touch upon it in some lectures, but we'll try and look at it, and we'll also look at how, you know, things from your biosphere, such as plants, can be used to get rid of pollutants. Microorganisms can be used to degrade pollutants, etc. So hopefully we'll look at some aspects of those there, but it's both managerial and I think environmental crisis that needs to be sorted. So are we ready to jump onto the lecture?
Yes, ma'am. Yeah.
Okay, great. So today we'll be looking at plastic pollution, but I wanted to give it the name of plastic pollution, but we can't really talk about plastic pollution without talking about solid waste in general. And of course, we'll be looking at the kinds of plastic that there is. And then, you know, when you talk about solid waste, it of course is the waste that's not liquid. So all of this solid that's lying around you, but it does not refer to the waste, the excreta in your liquid wastewater or your municipal wastewater. So the excreta doesn't count. It's just the solid waste outside of your wastewater stream. And why is that important? Because it's a nuisance when you look at it, but other than that, it has a lot of contribution on different agents in the environment, and some of them can be pathogenic and health related, and others are just, you know, not good for the site and not good for the surrounding environment. Because I've been trying to get multiple aspects on a lot of things that we discuss, I think in the solid waste, I wanted to mention the fact that we've generally read about the Anopheles mosquitoes with reference to malaria in developing countries. But what we don't know is that all of these three genuses of flies or mosquitoes are, which is Culex, Aedex, and Anopheles, they are all breed at waste sites. So waste sites or dumping sites or cans or, you know, drums where you put all of your waste are perfect, ideal environment for these. So how do you create those micro environments in your man-made or artificial environments for such pests, for such diseases, for such pathogens to be able to grow in large numbers and then ultimately impact your own health? So I think there are a lot of those connections that need to be made. And let's not just look at solid waste as a solid waste and as a management problem, but also, you know, the health aspects of it. And it's not just that. I mean, wherever, unfortunately for countries like Pakistan, where we have dump sites and we dump everything openly, the dogs, a lot of other animals, because whenever there's food is scarce, and that's why these animals go there, right? If they had plenty of grass, or if they had plenty of other nicer sites to feed on, they wouldn't have gone towards these dump sites. But because we don't have those facilities, we end up seeing a lot of birds, cows, dogs in these environments, sometimes snakes, rodents. And that means that the chance of disease to spread increases. And it also means that the chance for contamination across the environment from one place to the other also increases, partly because of where it's placed and how water and air and other things could take it away, but also partly because of its interaction with the biosphere in the environment. And every time you talk about solid waste, you can categorize it in many ways. generally the types of wastes are segregated based on the sources. So could you combine municipal solid waste with institutional waste? Could you combine residential waste with commercial waste? You could, because the commercial facilities and the residential facilities could have food waste that can go combined. They could have paper, pulp, other things that could be combined and taken care of. So I think from the management perspective or the managerial perspective, it's important for you to know what the source of the waste is, who's generating it, and are there any special components in it, and then how would you maintain it, right? So based on its properties, then you would decide on how can the waste be managed. And of course, I've just put it there for you to read later. You can see that there is multiple sources, sites, and therefore types of waste. And if you look at those types of waste, their management, you can automatically already look at them and think, what would I do with this waste, right? So for example, I look at the agricultural waste, and then I'm thinking, oh, spoiled food waste, can I convert it into compost and use it on source? But then I look at hazardous waste and I say, oh my God, I should be careful about reusing some of those waste that comes from the agriculture, because if it's a pesticide intensive field, then do I really want to bring all of that organic into my garden just for it to be composted and actually import all of that pesticide into my garden? So it's just for you to look at this as a broad term. And these are the standard definitions that are decade long and exist in many books. So just for you to have a quick look at the knowledge that remains on the books and standard definitions and types. But like I said, those definitions, a knowledge of what they contain, a knowledge of where they come from, eventually help you in managing that waste. And to make it more simple and also to kind of relate it to the terms that we've been using in this lecture, we've been using terms like organic. We know that there is plastic waste that would fit one of these wastes categories, such as combustible. Plastic could totally get in there. So now you're categorizing them into another component. And this year when I was in the North, I went and met the GB waste management company to see what kind of issues they're facing. And I had not expected it at all, but the two major issues that they were facing was, firstly was diapers, because generally we have a lot of food waste, and the food waste is often given to the livestock. And even if it's not given to the livestock, it's easy to degrade. So no matter where you put, even if it's a family pet, you can sort of take care of it. But now with wastes like diapers that are they're complicated, right? Because where do you put them? If it contains plastic, do you put them in the combustible? But now if it's coming out from municipal waste, it also contains some organic waste in it. So where do you categorize this? And the more complicated the categories become, the more complicated its management would be. Because then how do you deal it? Let's say if it was recyclable and you could recycle it, does it mean that you wash it, take off all the organic first, and then recycle it? Can it be recycled, given that there might be bacteria that would come out? And sometimes if the person is sick, what kind of bacteria is coming out? All of those teeny tiny things. So they said that their biggest problem was the waste in the form of diapers, and also the slaughterhouses. So the waste that was coming out of shops that sold meat, because of that waste, they had a lot of dogs coming to the site. And now that transfer of disease and finding a certain population of life around waste, all of those things that we had never known or seen, because prior to this all of the waste was managed inside the house, but now populations are increasing, spaces to manage life is decreasing, because we had a lot of space with our house to manage a lot of things, but now in most of the cities they have very limited spaces, which means that they want the waste management company to just come and take their garbage. And so it's becoming more and more complicated. And I wanted to mention it here because we've had, mentioned one term or another in different sites, such as, hazardous waste. If it's coming from a medical facility, it's not a normal waste that you could mix with any other kind of waste, etc. So just for you to get a sense of how complicated this area is before we jump to a particular kind of solid waste. And just because there are a lot of people from the management, I thought I might as well mention how solid waste is managed. You identify, of course, the waste, you identify the source, you determine its hazard, and based on the hazard, you then look at the volumes that are generated. Then you would identify a type of collection method. So do you just want to send one person who collects it on the cart, or do you want to send a big container, or do you want to send a rickshaw? Like, what do you want to send? And also based on what facilities your waste management company has, you would send a transportation and collection method, and then finally dispose it properly. But something that has evolved during this field is the concept of zero waste, or the concept of sending no waste into the landfill and kind of reusing everything close to home, right? Or close to source, or making sure that we're producing very little rubbish. Because some of these, as we read, are persistent, stay in the environment for long. So now concepts like recovering it, reusing it, repurposing it, or terms like waste to energy, and this particularly applies to waste that is combustible, right? So the combustible ones, you'd make sure that you recollect them, and then you would see their energy values, and then you would use it for, and wherever the energy demand is high, you will try to make energy out of it, and perhaps use it for bigger applications wherever energy is required. And then the material recovery facility, or MRF, is kind of the same. It could be a pre-step to waste to energy, where you recover whatever is required before you finally throw something into the landfill. For example, the organics you could completely recover and turn into fertilizers. The combustibles you could completely recover, and sometimes some of them could be recycled, some of them could be burnt and made use of. So all of those concepts where from generation to disposal, you make sure that most of the resources are recovered and used. And because I've also been using the term landfill a lot, I thought it wouldn't be fair to just let go of this term without really explaining it to you. You basically select a place or a piece of land, you exclude it from its surrounding environment using a liner or some form of isolation, and then you put all of these the waste past, extracting as much as you can out of it, and then whatever cannot be reused, whatever cannot be recycled, whatever cannot be degraded, you send it to this piece of land which is engineered, and then you send it there, and you sort of compress it and cover it with a layer of soil to make sure that it collects as much as it can until it's completely filled. In that process, two things are most important. Because we're concentrating the waste, because there's chance for the water or the liquid or any moisture that's inside it to go down, in that process, the liquid can come in contact with different kind of hazardous chemicals, because what's going to the landfill mostly is toxic, hazardous, and other things that are not needed or are dangerous. And sometimes food waste as well, as a mixture if we are sending it. That rich liquid, which is highly concentrated in all forms of hazards, is called leachate, because this term was also mentioned somewhere, and I think someone asked me to explain it. Liner. Rafe liner is let's say it could be one of those plastic layers, thick plastic layers, the PVC layers that is used sometimes to separate one piece of land from another. So you kind of use it as a separation material from its surrounding environments. So whatever you're using, it could be gravel, it could be compact sand, but you kind of create that atmosphere where you make sure that there is whatever's inside doesn't pass to the other side. So the generic term for it is liner. And mostly thick plastic materials are used to make sure that you keep the aquifers or the groundwater clean, right? And specifically from leachate. So leachate, you have to kind of collect, you have to treat it, you can't just keep it there. Otherwise, if it remains there, there is a disruption here. And then if it goes down, then it can contaminate your groundwater. And a lot of processes are happening here. If there's biological waste, methane, as we said, would be released. In these areas, ideally, there should be a groundwater monitoring facility and certain chemical, biological, and physical reactions that are going on here kind of take care. So this is one disposal method that I wanted you to look at before we
Ma'am,
Yes.
ma'am, regarding the landfills, like um, people in my place usually, bury these solid waste in the ground, but they really do not use these methane recovery or these liners. So in this way, the chemicals may react, and that can give rise to more hazardous results. So is that more dangerous than keeping the garbage in open? Because there is no proper system of these burying things in the ground because they don't use these.
So if they're burying it in the ground, then they should definitely make sure that it's non-hazardous, which in most cases it is, because I think they probably bury the plastics and a lot of those, and we know that they contain a lot of chemicals that can leach out. So they should definitely use a liner, because now there are waste management companies. They should speak with them about engineered trenches or landfills where these waste can be sent, properly compacted, and made maximum use of. And also I think, yeah, I mean, if it's not there, then it's a shame. Instead of managing it yourself, it probably would be ideal to hold your waste management companies accountable for collecting the waste, but of course with the first step that you don't discard everything, and your refuse is as minimal as possible. Eamon, did you raise your hand?
Yeah, ma'am, I just wanted to say, can you please let me in? I'm waiting in the waiting room because I wanted to sign in through my laptop.
Sorry about that. I thought I had made Summer the host, but Summer's also in the waiting room. Okay.
Thank you, ma'am.
All right. So I'll keep it here so that I can also see it, although it distracts me a lot. Okay. So this actually is not an example of a landfill. This is an example of a complete mismanagement in Al-Azhar, which is one of the historic cities in Islamic history. And this particular site was, I think, it was rehabilitated by one of the Akkadian projects, where this place, which served as a dump site, where all of the dump site for many years had come, was finally converted into the lungs of the city. So what used to be the pollution site in the city, or the pollution dump site in the city, was finally converted into the lung of a city where now all the trees thrive. But that process was so complicated. So I think when I watched the documentary, or the process through which that had happened, of course, with community integration, with a lot of scientists, top-notch biologists who had come to see, what because they had a plan, then they grew those plants. Those plants could not grow because the land was so hazardous or toxic. And then eventually, they were able to recover or rehabilitate the land and convert it into what you're seeing on the slide. But ideally, when you have these engineered systems, when you are actually properly taking care of waste, when they're filled and when there's no more, because you're compacting it all the time, when it's eventually filled, when it runs out of space, then ideally this is what a filled landfill should look like. Now think of this, and then think of all the dump sites that we have in our country, and forget even dump sites, the open dumping grounds that we have in our streets and other parts. Because like I said, environmental management manages the environment such that your impact on the groundwater, your impact on the surface water, your impact on the wildlife and biodiversity, your impact on the atmosphere, everything is minimized. And just looking at this, it doesn't even look like a site that might have ever been used as a dump site. So just motivation for you to make sure that our waste is being properly managed. And because we're speaking about disposal, I might as well just quickly mention some of the other ways in which waste is taken care of. Composting, I think, is a very common term. You all know that all the organic waste, the waste that is at home, easily degrades, easily decomposes with the help of microorganisms and the physical factors from the environment, the sunlight, the heat, the bacteria inside. And then you can basically just convert it into soil or organic matter or fertilizer, which becomes a part of your lithosphere again. Incineration is the process where at high temperatures, and the temperatures are quoted differently, but when we studied it, it was somewhere around 1200 to 1500 degrees Celsius. Some papers also quote 800, but then there's pyrolysis as well, which could occur at 500 degree or so. So at these varying temperatures, you can burn at a high temperature to make sure that a very large volume of combustibles is just shrunk to a very small volume. But the problem with this process is that a lot of toxic air emission takes place when you're running incineration, because most of these combustibles are plastic and other products that are that we already know come from fossil fuels and could contain a lot of these chemicals and dioxins and furans that we've been talking about. And recycling, as you all know, is just bringing it back to its original form, reusing it, and then if it's a plastic, turning it back into a pellet and turning it back into the bottle that it was when it came back to us first. Does anyone have a comment? I just quickly want to check everyone's admitted. Okay. Okay, now. So now we leave the solid waste behind and we look particularly at one kind of solid waste, and Hassan has a question.
Miss, the thing you're talking about, like using the bottles again, isn't that reusing? Like recycling is supposed to be different, right?
Yeah,
it's more like repurposing.
Reusing but what I meant by recycling was that, let's say I used a PET bottle, it went into the recycling plant, it was converted into those pellets again, and then it was again converted into another bottle, and then it comes back to my house. But I think you've raised a good point, because now for people who are very pro recycling, they can think about how the same bottle that could be reused is now being sent back into the recycling facility, back to the factory, and then comes back to me as the same bottle after going through so many processes that are energy intensive and of course environment pollution intensive as well. But yeah, that's what I meant when I said that a plastic bottle gets recycled and comes back as a plastic bottle to me as a consumer.
Right, thank you.
Thank you. Okay, so this is just like a little bit of history. Not all plastic is synthetic. There's a natural plastic as well. So anything that is based on celluloid, cellulose, cellulose nitrile, the silk that we see, the rubber, all of those are natural plastic, or what we could call bioplastic, because they come from those renewable sources. But what really revolutionized this area of plastic production and plastic pollution and plastic as an environmental hazard was turning ethane and propane into ethylene and propylene, and then converting them into plastic. And of course, it evolved from the petroleum industry, as we have studied before. And I'm bringing this image back because I just want you to relook at these things, just to simplify it, not complicate it too much for you, but kind of going back to where we started all of this discussion. We said that crude oil gives a lot of products. And I have often mentioned that plastic is actually a product of crude oil. And where the plastic comes from is called naphtha, and naphtha is mentioned in this particular graph, figure. And I think a lot of you, when we had the initial discussion, discussed how the air was clean when COVID happened. But very few people discussed how drastically plastic pollution increased in the form of single-use plastic, of masks, gloves, other PPEs. And that had increased. The single-use plastic in the form of plastic pollution had increased because the oil prices had come down. And that's why the raw material was cheap. And because of the raw material being cheap, you could just see an increase in the production. But how does this look for Pakistan? Pakistan has about 6,000 plastic units or more, because this is a older report, 2 or 3 year older report. And it's one of the fastest growing industries. And you would think that because we have some natural reserves of crude oil, probably we are producing all of these products ourselves. Unfortunately, some of the raw material that we use for all of these products that we are creating, plastic products that we are creating in Pakistan, is imported from UAE and other Gulf countries. The high quality ones are imported from Germany and USA. And now even more lower quality raw materials in the form of naphtha or those beads are imported from China. So, and again, I just want you to think at the scale of this being polluting, but for us to not only produce a very poor quality raw material here, but also import it and kind of increase our share into environmental pollution. And this is specifically for people who are chemists or biologists because they should know about it, but also for you to understand the same graph, right? If I say, for example, in the future slides, I'll mention things like BPA or phthalate, and I will say that they're additives. And you might think, where did the additives come from? So the additives are essentially something that you add into this. The plastic then doesn't remain pure plastic. So crude oil, you take naphtha out to make it more to make it more elastic. You would add certain additives into it, and sometimes those additives also have very negative impacts, and etc. Atka, you've raised your hand.
Yeah, ma'am, I'm just confused about the previous slide. Like, I just have one question. कि जो crude oil की, you mentioned that crude oil prices they did affect, the plastic usage. So, was it like that crude oil prices decreased, and then the plastic usage increased, or since plastic usage increased, crude oil prices decreased? So, which way was it?
Yeah, so the crude oil prices had come down during COVID, right? And we can talk about that. I mean, I'm not an expert in economy, but we know because its use came down, factories were shut down. Let's say that was one of the incentives for it to come down. But whatever reason caused the reduction in the crude oil price. So if the prices were decreased, but people weren't really going out, factories weren't really running, that means that the demand on that end was low. But there was another triggering demand, and that triggering demand was for PPEs, or those personal protective equipments in the form of plastic products. So what happens and how these companies really exploit you and your behavior is that product was then used to mass produce another form of pollution, or another form of personal protective equipment which contained plastic or contained a certain concentration of plastic. So that reduction in the oil price was increased the plastic use, but it had to do with COVID and the need of COVID. That is, to protect yourself, you use those personal protective gears. And to get those personal protective gears, you need to have them in bulk supply, right? Not only in the cities, but also in the remotest of villages. And then you mass produce them, and you export them as a mass scale. And you've probably seen a lot of aid coming from all across the globe to Pakistan and to other countries in the form of PPEs. Of course, someone created them, and someone bought them, and someone shipped them to where they were being used. But I think it's just for you to look at things from a certain perspective. And we have never really spoken about it. But a lot of you said that during COVID, the sky was clear. So is clear sky an indicator of clean air? Can anyone answer this? Let's say on a normal day, the sky is clear. Is the air free of pollution? Fateh?
Am I audible?
Yes, you are.
Yes. Concerning specifically the current days of COVID, I would say that to some extent, a clear sky does mean a cleaner sky, because during COVID, because of the global economy, when factories were shutting down, workers were being laid off. So now there was much less manufacturing activity going on, and therefore there was a less emissions from factories going up into the atmosphere. And and we can tell by this that there were fewer pollutants going into the atmosphere too. So therefore a cleaner sky a clearer sky would mean a clearer sky.
Yeah, compared to the sky. Am I on mute? No. So compared to the sky that we had, of course it was cleaner, but was it really clean? Aman, Aman or Aman?
Yeah, ma'am. Ma'am, in my opinion, it was cleaner in a sense that there were less vehicles on the road as compared to the normal days, as everyone was at the shutdown. and secondly, there was not any kind of construction taking place, so there was less amount of dust in our air. So we can say the air was cleaner than before the lockdown. And yes, as Fateh said, the factories were locked down, so everything, the main sources of emissions of pollutants in the air were shut down. So I guess the air was comparatively uh, cleaner for that time of period.
Comparatively clean, but not completely clean. Because if you remember all the air pollutants that I taught you, I specifically mentioned one of their characteristics, and that characteristic was that they are colorless. So although particulate matters are visible, or though pollution in the form of smoke is visible, although smog becomes visible, a clearer sky does not really indicate clean air. At least we don't analyze it here. But if noxes, SOxes, carbon monoxide, they're all colorless, then a clear sky could mean that a sky contains all of those, number one. And number two, remember I told you that a lot of pollutants in the air are persistent. They can remain there for decades, right? We spoke about, so for example, let's say the troposphere was better, but we had, when we were talking about um, the stratosphere or the ozonosphere, we said that the chlorofluorocarbons remain there for many years and they can continue to do their job, right? So if that was the case, if they are really there and if they are really doing everything that they're doing, even though a recovery there was observed as well, but we talked about all of those things. So that's why in the environment, short-term outcome cannot really guarantee something. And seeing is believing, but because now you've studied this course, you should also make sure that seeing is believing, but also monitoring should be believing. Looking at satellite data should be believing. Looking at on-ground monitor stations that tell you what the quality of the air is should be believing, and not just someone saying, look how clear the sky is and perhaps this is the best air that we're breathing. You have not tested it, so you don't have the right to say it. Okay, someone else raised their hand and want to speak. Daniel, is it you?
Yes, ma'am. I had a question regarding the smog in Lahore. So is it that there are some extra chemicals which are coming into the air, or the existing chemicals are reacting with something and becoming visible?
So what did we study? I'm actually going to throw this question back at you guys. What did we study in smog? We said that there could be industrial smog or photochemical smog. And we said that a lot of what's coming as an exhaust from our factories, from our industries, but also from our vehicles, from what we burn, can also trigger the process of smoke. And so basically what they produce is particulate matter that is so fine that it remains suspended in the air. And it adds on to the fog or to the solvents that remain or to the water droplets that remain suspended in the air. And then they become visible. But we also said that, photochemical smoke could contain volatile organic compounds, they could contain ozone, they could contain noxes, they could contain a lot of other things that are not good for health. So they are both. They are the triggerers as well as the byproducts if it's being formed as a secondary pollutant. So they could be the primary pollutants causing it, but they could also be the secondary pollutants that are produced from it. Does that answer your question?
Yes, it does. Thank you.
Okay. Hamza, you had a point as well.
Yeah, ma'am, I was gonna comment like you said like if the sky is clear, does that mean that the air is cleaner? So like I was gonna comment like a friend of mine shared with me during the lockdown these two pictures of the Lahore Wateen show. On one, the first one was of 2nd January, where it's the sky is all gray and it has smog, and the AQI index was like 476. And the second picture was from 12th April, when we had lockdown and there were no cars in that area. So the sky was cleaner and the AQI went down to 37. So I was going to say like yeah, we should monitor AQI indices and all that kind of stuff to see if this air quality is better or not.
Yeah, Yeah, and but I also said that the monitoring of exactly what the smoke contains, or exactly what, because AQI gives you the visibility index, right? It just tells you how visible everything is, and visibility can be reduced due to natural fog as well. For example, on a nice rainy day, even Hunza's, the visibility there comes down as well, and that's purely because of natural fog and the clouds literally coming next to you. um, but that doesn't really mean that the sky is not clean. It is clean there, whereas we cannot say the same here. So I think you just need to overanalyze all the information that we've gotten in the previous slides. Just play with it. Okay, the sky is clear, but noxes, oxes, and carbon monoxides are colorless. So, and the particulate matter could just be dust, and dust is naturally found in the environment, and dust is okay. But it could also be volatile organic compounds. So we have never really analyzed the particulate matter to make that decision on exactly what is good visibility and what's not. Ideally, the visibility should be high, the air quality index should be better, that is the numbers should be low. But sometimes a very big number because of ordinary fog could mean healthy, and a relatively smaller number because of smoke, and completely smoke, could mean unhealthy. So I think you need to make those analysis yourself. Does that make it a little clear, or should I talk more about it?
I thought, ma'am, AQI also like mentions like if the AQI is high, that means that it's hazardous as well, not just visibility factors.
Yeah, so it just tells you the number of suspended particulate matters, right? And that too for particulate 2.5.
Okay.
Let's say micrograms per meter cube. But like I said, is it just dust, or is it something toxic? Is it lead, or is it just finer dust? So those kind of things also need to be analyzed. But it's proper research area and proper, I think, data information sharing area that should be available to the public. And a lot of people in COVID were also saying that even though the ozone in the stratosphere was healing during COVID, despite all the activities being down, in some places the amount of ozone in the troposphere was increasing, which we know is toxic to health, right? So who understands that, and how do you make such information easy palatable for the general public? How do you give even this information in a very basic way to the public who's listening to this? But and how do you make sure that such a research reaches people where they know that, okay, there's a difference between ozone in troposphere and the stratosphere. We know that the stratosphere ozone is healing, it's the good ozone, we're really happy. But no one really told you during that time that unfortunately the ozone in the troposphere was also increasing, which is a toxin here and as a secondary pollutant. So what was causing that, despite the fact that all of the factories were shut and most of the cars were just parked home? So I think those researches also need to happen. And we now, me and you, because of the fact that we know more about this, should be reading more about this and should be talking more about this to people or to our peers or to people, just our family, to make sure that this information it becomes public and they know more about it. And it's not just a discussion on the PM values, but also what kind of PM, what does it contain in reality. So that kind of chemistry research. All right. So we're discussing more air and solid waste, which is always never a bad thing to go out of the zone to discuss the environment. But why do we care about these plastics? Okay, first of all, in every lecture I say, whatever I mention, whether that's SOxes, NOxes, lead, persistent organic pollutants, I always say fossil fuels cause it. We studied about fossil fuels in the previous lecture. We also said that plastic is a byproduct of crude oil. We also looked at how naphtha is produced from crude oil. Now we are saying that these have very long life or a very longer life cycle, and they can remain on the planet for many years, and that's why we should reduce their use, right? This one kind of solid waste that is so apparent everywhere and is used so conveniently everywhere, we're not aware how long this is going to last. Some of this is going to last for maybe our next 5, 6, 7, 8 generations. So we'll die, but the plastic bag that I used could be there lying somewhere. So I think sometimes you also need to be accountable for what you're using. And another debate that maybe we can have in the next lecture is the fact that when plastic converts or degrades and is not visible to you as plastic, it could still be available in the environment as microplastic. So it's not visible to you anymore as plastic, but it could have divided into 1,000 pieces and might still be lying around. And that's why oftentimes for plastic, people say that it takes thousands of years to degrade, because those microplastics could be lying everywhere around you. And these states, the statistics change as well. But to quickly look at it, because we are focusing on plastic, what's the most important thing for us would be the fact that it's not dangerous for our health. Whatever we are using for, we make sure that it serves the purpose, but also make sure that once it's redundant and we don't need it anymore, it can be recycled and that it doesn't end up in the landfill. But mostly, I think we're concerned about our convenience, but also the impacts that it could cause on the health. And I had asked you to keep like a plastic bottle next to you. If you have it, just pick up the bottle, and at the bottom, and actually at the bottom of every plastic product that you use, you should see one of these numbers. And those numbers tell you which kind of plastic it is. So whether it's a polyethylene terephthalate, or whether it's a polypropylene, or whether it's a polystyrene. And generally these categories have been made with reference to recycling. So if it's a PET, it's definitely commonly recycled. If it's a high density polyethylene, it's definitely commonly recycled. If it's a polystyrene, those white styrofoam cups that you use for drinking coffee, it's almost never recycled. So you should almost never use it in your daily lives. So those basic decisions on the environment, and I've briefly introduced all of them to you because I think you should be able to tell what goes where, and you should be able to know, if you pick up a cloth that you're trying to buy, just look at, sometimes the clothes just have it written on them, right? 30% cotton, or cotton blended with PTFE, or cotton blended with PET. So you should be able to know what exactly those things mean and what they could mean for the environment. Rafi, you have a question?
Yes, ma'am. I was just gonna ask, for like most things we can find alternatives, like for things like, for example, diapers, वगैरह, and like how do you eliminate, like, for example, Pakistan, where there was a movement on like plastic bags, or plastic bags ban हो गए थे, लेकिन plastic bags, like we saw in 2 slides before, are maybe like less important than disposable cups and diapers and so many more things that we use just as frequently. So like ये तो हम मतलब कोई अच्छा काम तो नहीं करे बस प्लास्टिक बैग्स खत्म करके तो फिर बाकी चीजों को छोड़ रहे हैं. Do we have any alternatives for anything else? We have to live with this.
Why should we live? How did we live without before plastic came? And I just said it was actually it revolutionized around 1950 when it was produced from crude oil. But prior to that, how did people live? How did humanity survive? And that's why I often use the term convenience, Rafe, because we are so used to just thinking about this particular moment, this particular second where I need to do something, where I need to carry something, that we forget that we're going to leave that single-use plastic for thousands of years into the environment. I mean, you can look at the pros and cons, and you might have your own way of looking at things. So maybe some of you say, I live today, and I'm responsible for living a better life, so I just do whatever is convenient. I do not mind taking my cloth bags when I go for grocery. And I've been told when I tell them not to use any plastic bag and just put all the vegetables in my bag, they say, Baji aapko dhona padega. So I don't mind it, I'll wash it. And then I bring these cloth bags because I don't want to use plastic bags. और वो कहते हैं कि लोग तो अपनी बेइज्जती समझते हैं. Like, how did we fall so low on izzat and बेइज्जती to decide कि अगर I take a cloth bag from home, ये किसी तरह से भी मेरी बेइज्जती होगी? Because I think it's, why is it such a bad thing? I think you're just being responsible, and you know that whatever you're carrying, you can reuse it multiple times. That plastic bag or that polyethylene bag could stay in the environment for such a long time, but that reusable bag will stay with you perhaps for many, many, many years, if not decades. And I think it comes down to responsibility, and it comes down to how willing you are to make radical changes to stop the environment from being degraded, but we'll also look at the health impacts of it. When you know its impacts or the impacts of the additives or the products that leach out of plastic onto your health, maybe that will concern you about its use. And I've often said that I'm not an anti-plastic person, right? So all the descriptions that I have, I've put their strengths. So what the industry would put, such as high heat resistance, good moisture barrier, I've put all of those in the definitions because I want you to know what their strengths are and why they're used wherever they're used. But I'm also radically against it for the fact that, you know, I cannot imagine for them to stay for the next thousands of years onto the environment. I think that's my responsibility as a human being, as someone who's educated, to know that, you know, why would I keep a plastic bag for 20 seconds if it's going to end up being on the planet for that many years, especially if it has negative impacts on it. Let me quickly read the chat. Why does PET need a gas and a moisture barrier? Because the gas barrier, because of your fizzy drinks. So when you drink Coca-Cola, what do you want? You want it to be completely fizzy. So what do you expect? The gases to remain inside. And that's why a gas barrier would be very, very good. You know, and of course, moisture, you want your liquid to stay in, you don't want it to evaporate. So all of those qualities reflect their uses in the industry, in our everyday life. So we know, you know, that they're commonly recycled. We also know this one's commonly recycled. Again, they have properties, and those properties encourage us to use them in the products that we use them in. And all of them, at some point I might have written, are dangerous to your health because they leach chemicals, but HDPE leaches less chemicals than the others. PVC, all of you computer scientists, all of us who rely a lot on electronic gadgets, a lot of our gadgets actually contain PVC, which is almost never recycled, sometimes recycled, but mostly never recycled. The biggest problem with e-waste is people trying to burn it and releasing those dioxins and furans that we mentioned in the beginning of this slide, and contaminating our air, our atmosphere, to take the copper or the metal out and sell it, because it's more valuable. It's gives them a good price. And if you see here, it says this kind of plastic should not come in contact with food items because it's harmful if it's ingested, excuse me. But you'll also see that there's a toy in there. And I know my nephews and nieces chew the toy all the time. And if they're doing it, and just look at the bottom, if it's actually PVC, make sure that you don't buy it for your family members. And similar to the high density polyethylene, there's LDPE, or of those thin foils, relatively soft bottles that you use. Again, they're sometimes recycled, sometimes, and also like be careful of the terms that are given in these in these industrial pitches. Sometimes recycled is one way to put it, but if I had to teach it to you, I would have said they're only sometimes recycled and mostly not recycled. So always be wary of what you're being told, right? And again, I've given you all of those strengths that the industries sell to you, but these terms that sometimes recycled, but mostly not recycled, you should be intelligent enough to read between the lines when it comes to products that have negative impacts on the environment. Polypropylene, again, just look at the term, occasionally recycled. And we use a lot of chemicals that are reactive. We want them to be separate from our environment. We don't want them to become a part of our environment. We want things to, the bottles, the packaging to have higher withstanding for temperature, chemical. And that's when polypropylene sort of comes in, and you use different products, especially your food containers, your margarines, the boxes that we have, the ketchup bottles, they're all PP. And of course, you should see the sign for that as well. Polystyrene, they say commonly recycled, but mostly it's not recycled. Like, again, it depends on what you're reading and where you're reading it from. An industry would always tell you that selling it would tell you that it's being recycled, but generally it is not recycled because it has a lot of food products that stick on it, and then it's difficult to wash it and then recycle it, so it just ends up being in the landfill or the dump site. And then there's a category 7, which contains all of those other plastics, which are also very hard to recycle. But generally, I think there are top 20 plastics that are frequently used, and out of them, these 6 are the most prevalent ones, especially when it comes to recycling. Azhan, where does your PAM fit in, your polyacrylamide? Do you know?
No, ma'am, I'm not sure. But definitely it's not recyclable.
I think it's category 7. Okay, so so Azhan's working on PAM and coating it with titania to make sure he degrades something into the environment. Is it to give antimicrobial properties, or is it for dye waste removal? Right?
So basically, it's the photo degradation for now. But we will definitely check the antimicrobial properties.
Right. Titania has great antimicrobial properties. So I just guessed you're probably looking at that. Anyways, so Azhan's research contains one of those plastic products, and I thought I'll just mention that and also see if he's there. And plastic pollution it's simply the accumulation of plastic. It's creating an environment for the wildlife, and it destroys their habitat. The data shows that it is, from in the 1950s, as I said, when it commercialized, the amount is increasing so much. And right now, let's say if our population is 7 billion, every person on this planet is releasing more than 1 billion ton of plastic. So something for us to be wary about, I think. And then if you look at the disposal, most of it, so we read terms like recycle, right? We know recycling is also requires some energy. Like I said, you collect it, you send it back, it's additional work for something that's already not good for the environment, but it's better than it being discarded. But most of the plastic waste is still discarded. And incineration has its own problems, like I said, in the form of flue gas or the gases that are toxic. But a very little percentage of the plastic that we are throwing into the environment is actually discarded, recycled, and most of it is discarded. And if you look at the percentage of it, it's definitely packaging that dominates. So because we're buying everything in packaging, so how can we go local? How can we go to our local farmer and buy potatoes in our own bags instead of going to these big fancy stores and make sure that everything comes in plastic? How can we just go local, go to these farmer markets and buy things, fresh, also improve that supply chain, and also reduce plastic pollution. But I don't know why I just keep targeting the people who have to do with electronics. See, we also contributing there. So every sector has its own contribution. And how does textile become a contributor to plastic? It's because of the combinations that we talked about. That cotton certainly comes in combinations with other forms, and a lot of things are actually, if you look at the products, it would definitely say which kind of plastic, but PTFE, PET, a lot of them are generally a part of the products that we use. And if you're thinking that we're not a major contributor to the plastic that's found in the ocean, we actually are. And if we don't make it to the negative list, then who are we? So we are unfortunately on this list as well. We have our contributions to the plastic debris that's entering into the oceans. And that's another reason for you to make sure that we do something about it. Talk about the assignment. Okay, Nadia wants me to talk about the assignment. And then the impact on the biosphere. I think other than them turning into microplastic, other than them absorbing toxic chemicals, other than them leaching toxic chemicals, the simple change in the environment, for them to think it's their food, them being entangled into all of those nets that we put into the environment, I think it just breaks my heart. Chris Jordan has worked a lot with how these birds are, they mistake the plastic as their food. And then he's this brilliant documentary and pictures that kind of break your heart when you look at it. And yeah, and also like the same thing when they mistake the plastic for food, even if it's broken down into smaller pieces, how can you end up finding it in your food chain? And that is why you should care. And how they change your environment, right? How they change your otherwise natural environment, and how they just integrate into your environment. And it's a shame that we don't care and we still continue to use it. Manal, you have a question? Manal, I cannot hear you.
Can you hear me now?
Yes, I can.
Okay, I was saying that I remember that in the beginning you talked about how there were some microplastics that had ended up in the ice in the Arctic, like in the glaciers. So I wanted to ask how that happens if there is no trace of microplastics in the vicinity. How are they ending up in these remote places?
Yeah, so that's a good question, and I hope we can discuss it in detail in the next lecture. But remember, I said that these microplastics are also very, very micro. They are very small scale. So the biggest go from 0.5 mm, and then the smallest are super small, like they are the size of a bacteria. So they're not visible to your eye. And very often they are transported either with water or with air. So we spoke about those air currents. We spoke about air transporting certain pollutants from an area where the pollution doesn't exist to an area that's pristine. But because they're so light, it is expected that even in the evaporation and the water cycle, them becoming a part of the ocean debris and them degrading in the ocean because of the physical environmental factors such as UV, light, air, wind, whatever you call it, and also like the biodegradation where the microorganisms or certain worms do that, the sizes become so small that they can become a part of your hydrosphere. So they travel with your water, or they become a part of your troposphere. So they travel with the wind that is passing by. And yeah, and unfortunately that is what it is. That's how we are evolving our natural environments with the built environment. That's how we are changing a lot of things about the environment. And I think we still have to learn a lot of things about it through research. Yeah. And most of the plastic that we use, and this figure also varies, is single-use plastic. Particularly in this, generally for the world, they say it's around 40%. In some countries, it's even 90%. 90% of it is single-use, and very less is recycled. But about the additives that I've been talking about, the bisphenol A or the BPA and the phthalates. I don't really pronounce it very well. So the phthalates and bisphenol A, they've been known carcinogens, neurotoxins, all of those toxic effects that we've been studying at different levels or in different lectures. We will, it's kind of highlighted in the slides. You can read it. Someone raised their hand. Who was it? Okay, I don't know who raised their hand, so I'll just continue with the.
Ma'am?
Yeah.
I raised my hand. I have a question. So I just want to ask about polypropylene used for straws and paper cups. Is that the cheapest form of plastic available?
The cheapest is, I think, polyethylene, the bags that we use. Because it's what?
Yeah,
one rupee, one plastic bag?
I was asking because I think polypropylene is like single-use plastic, as you were talking about. So if it's not the cheapest, is there like a proper substitute that's been presented as to be used instead of straws other than paper?
Yeah, I'm happy that you're already thinking about it. So a lot of plastic or products that are used for these, so the first thing would be, and I think it's a very discouraging answer. I should be more kind in my responses, is why do you need a straw to drink something? What happened to drinking things in the glass or drinking things with your mouth? So first of all, there's no need for a straw to drink something, unless it's too acidic and it could affect your teeth or something else. There's no need for you to use the straw. But if you must use straw, people are now taking steel straws with them. So they take the steel cutlery with them wherever they go. Or a lot of restaurants are offering bioplastic, so plastic that has come from biological sources. So let's say at times from sugarcane or from banana peel. So they're using that. And I've even seen in festivals abroad, they now serve you food in trays that are edible. So they're made from, let's say, avocado seeds. And after you're done with the food, you can just eat that plate as well. So people go innovative with a lot of things. So yeah, there are alternatives available, but I think the first step is to not use it at all. And I see that someone's mentioned that a lot of companies are now going towards bioplastic or trying to reduce their plastic use. There's a little bit of discussion that we need there as well. So I'll let you look at this contamination. Again, the vinyl chloride, the benzene, the dioxins, the furans that we've discussed before as well are not good for your health. And yes, the bamboo toothbrush and the bamboo products are also dominating the alternative use for plastic. And bisphenol A, which I think has been related to the PET bottles that we drink a lot, that if you leave it in the sunlight for a lot of time, then it impacts your health. It's not good, especially for reproduction and reproductivity. And I think one word that I've continuously been using, and I would want you to think about it, is the word persistent. Whether it's plastic, whether it's chlorofluorocarbons, whether it's hydrofluorocarbons, whatever we talk about, or if it's POPs, right? That is the polychlorinated dibenzofuranes or dibenzo dioxins. They all are harmful because they're persistent. They remain there for a longer amount of time. So whenever you're looking at things, whenever you're making a decision for the environment, and by the way, things like balloons that are made of plastic, glitters that are made of microplastic, a lot of choices that we make, they have plastic products in them. And I think we need to think about those choices that we make. And yes, recycling is one activity. Yes, reducing the waste to make sure that nothing goes into the landfill or the dump site is important. But I think it's gotten beyond reduce, reuse, and recycle, which is the 3 R's of reduction of waste. I think it's now multiple R's. It's rethink your choices. It's refuse, it's reduce, then reuse, then refurbish, then repair, then repurpose. And even recycling should be your last step, because that too requires a lot of energy. And one thing that I think we aren't told is that even for recycling, there's also until a certain extent that something can be recycled. So a few products, because it becomes contaminated, right? So it becomes hard and hard for it to be recycled. So it can be recycled up to a certain number, and then eventually it has to be dumped into the environment. So you need to know all of those things. We've already discussed this. Summer is going to discuss her microplastic research with you in the next week, combining it with bacteria, because we'll be studying microorganisms. So I'll leave it there. But quickly, I wanted to discuss biodegradation, because you would say, so but what exactly happens to plastic? Not all plastic's lying there, right? Because if it were, we would only have plastic on planet Earth. Most of it takes a lot of time to degrade, but there are natural worms, such as waxworm or mealworm, that can degrade it. There are bacteria even in the tummy of these worms. There are actually bacteria such as the one mentioned here, Enterobacter and Bacillus species, that are able to degrade these polymers. And of course, some polymers are tough to degrade, some are easy to degrade. In this particular case, it's just a polyethylene film. And now I have a quick question for you, which is, what's the difference between degradation and biodegradation? And in the meantime, I can read the text. So I said biodegradation is where life is involved in degrading something, whether it's in wastewater, whether it's in degrading solid waste, whether it's in degrading food. Degradation generally refers to physical factors in the environment that cause degradation, or chemical factors. So for example, if you're using a chemical, it's not really biodegradation, is that you're using a certain chemical to degrade it. In the case of plastic, for example, it's often combined with degradation. So it's exposed to ultraviolet lights first, so that kind of weakens the bonds. So I wouldn't want to go into the chemistry, but let's say you expose it to the UV first, And then you introduce the Bacillus species or the Pseudomonas species or the Flavobacter species that is able to degrade it, and then the time goes down. And so it's degraded easily. So that's degradation versus biodegradation. Yes, Hassan.
Yeah, ma'am. So I wanted to ask that does deforestation comes under the biodegradation or just a simple degradation?
Okay, thank you for asking it, because whatever I was referring to right now was just in terms of getting rid of waste. And I was only referring to degradation of plastic or degradation of solid waste or degradation of waste that is present in wastewater, right? The nuisances that are present there in the form of chemicals. And for them, I was just comparing that sometimes UV light can also degrade the chemicals. Sometimes the bacteria can use oxygen and degrade that chemical, or the sugar and release carbon dioxide in water. So that I was referring to as biodegradation and degradation. And I think degradation of the environment or degradation of our biological habitat or our biomes is another way to look at it, which doesn't really fall in the current explanation that I'm giving you. Yes, it's degradation, but these two degradations are entirely different things. But yeah, that would be degradation of the environment in a way.
Okay, thank you, ma'am.
Welcome. Someone else raised their hand. That's such little time. Right. So while you're making your mind to speak, I just said bioplastic comes from renewable plant materials. It can be starch-based, it can be protein-based, it can be organic polyethylene, for example, that comes from agricultural waste. So a lot of people are, becoming innovative with this idea. But there's the discussion that I was having about bioplastic was the fact that bioplastic, which is either biodegradable or compostable, needs a certain environment for that as well. So a lot of pro synthetic plastic people would lobby against bioplastic because they think it takes equal amount of time for it to degrade, because if it's not given that certain environment that it needs to degrade, it would still take some time, not as much as the synthetic plastic, but more time than other things. So this question I had for people in the chemistry. So there's like this case study, and this was majorly for people from the social sciences department. I think you can just look at it, where I worked with the waste scavenging community in Hakim Town. And this case study was just put there for you to understand the complexity of the issue. That I only worked with 50 to 100 juggies who were trying to tackle waste, from collection to segregation to selling. I just wanted to make it profitable for them, but I also wanted to make sure that it's hygienic. So focus discussion groups took place, a survey on collections took place. We surveyed them, and then we found a certain things. I think you can just look at it. And, these what I like about being open to discussion and ideas is the fact that sometimes when we're discussing waste, we forget the human, and we forget the humans who are involved in it. And we're also looking at it from the management point of view. But even to study this small community, it just became complicated because, hygiene and other things took a priority. I was there to improve their waste segregation and income, but I ended up working on their health more. So I put more questions on their health. So some of those findings are put there. It's basically, how do they get their basic things from? How are the women living in the juggi? What age do they get married? When do they have children? So it's all of those social aspects to something that we generally not look at when we think about solid waste. And in this particular community, I also try to look at their health conditions. The study is ongoing, but I wanted to share it with you for you to not just think about the chemicals, the degradation and that, but also multiple elements that could be associated with how it's being managed and who's managing it, et cetera, et cetera. And I think I'll give the floor to Roshan now, who has raised his hand.
Thank you so much, Dr. Fawzia. I know we are very short on time, so I'll keep it brief. My question is two-pronged. One is, can plants be bioengineered so that they can aerate the nullas even without enough sunlight? And if you can couple this with my next question, speaking of the nala that's right outside of lumps, do you think a layer of maybe an oxidizing chemical can be used to line that nala in order to aerate again the same water? Thank you.
Yeah. I mean, these are very intelligent questions, Roshan, and I need more time to, of course, explain it. Yes, phytoremediation is very common, especially for wetlands. This where plants are used to take up the nutrients from a water body is called phytoremediation, right? Just like if you would use bacteria, it's called bioremediation. So in phytoremediation, certain kinds of plants that can grow in high salt conditions, can grow in high nutrient conditions, can grow in toxic conditions. If we know that the condition there is toxic, then we can use those plants, grow them there to make sure most of the nutrients taken up. But I think they can take the oxygen and fix it, but I'm not too sure about how. Maybe by providing those roots, maybe providing some kind of movement, it would allow for more oxygen to diffuse in. But to be honest, I don't know too much about if a plant could be used to fix more oxygen, because in the end, the oxygen that we want is for, let's say, life underwater or plants underwater to be utilized and then to use other nutrients inside of that water body. But yeah, I mean, this concept can be played with. And the same goes for your next question, that of course certain chemicals can be used to do the same. If we allow for certain processes to happen there that release oxygen as a byproduct, then that can be done. Or simply we can play with flows, like how about we increase the surface, how about we make inundation such that the water, similar what happens to river, right? You either make it more turbulent and then it continuously comes into contact with oxygen, or you increase its surface area like we do in the wetland, so that it's a thin line and more oxygen goes for the life that's there, whether it's plant or bacteria. But these are all concepts that can be played with so much with just to solve the environmental problems. But yeah, they're very intelligent questions, Roshan. Thanks.
Thank you so much.
Any other point? So Nadia wants me to explain the assignment. I can do that. Does anyone have any other point before I finish? Sorry, I rushed through some of the slides, but they're easy, very easy slides. Taha.
Ma'am, I just also want to ask about the midterm, about what your expectations are of our prep. Like, is it specifically this having a good understanding of the slides, or should we do a little bit more than that by focusing on readings as well?
Having a good understanding of the slides should suffice, and also like something that I asked you today. Oh. About the air quality, for example. If all the information that I had given you should have been enough for you to make multiple assumptions, to make multiple explanations for it. And no particular explanation would have been 100% correct or 100% wrong. But that kind of skill where you're thinking outside of the box to explain an environmental issue or an environmental problem using those connections that we had used. So for example, if we speak about microplastic and then something that a student asked as well, I could have asked the same question of, why do you think did microplastics end up being in the Antarctic ice? And then you can use the explanation. But if I ask such a question, I will provide you some information. Let's say I speak about the wind and the inversion and some of those things. I can maybe provide some information on that as well. But it would be like, if you read the slides well, if you understand it well, you should be able to explain most of it. And I will design them such that they can use multiple lectures to explain that one question. Atka.
Ma'am, I just want to ask if you'll be holding office hours this week, because I have a project for another course, which is my topic is plastic pollution. So I have a few a discussion that I wanted to have with you regarding this and a few questions. So if you'll be holding office hours this week or next week maybe.
Yeah, I'll definitely be holding it this week. And I've always told you that those of you who are not available during office hours, you're more than welcome to take appointment with me outside of those office hours as well. For this project,
Okay, all right.
like you're more than welcome to write to me if you're not available during that time.
Okay, thank you so much.
Welcome. Rafa, you had a question?
It was really dumb.
Go ahead. Nothing is dumb in this class. I say a lot of dumb things.
It was like when we were talking about replacing everything, so I was thinking that if we get like bamboo toothbrushes and everything, so like with the current population we have in the world and the affluence, uh, we don't technically have
Bamboo on the planet.
yeah, or we don't generally have enough of the biodegradable resource to uh, get the economy functioning the same way.
Yeah, I mean, this is a very valid point that yes, how much harvesting is sustainable harvesting, right? If you're using plant-based plastic, if you're using plant-based materials for doing things, then at some point, in order to meet the demand, you're going to end up over exploiting that resource. And I think that's the same question that that I that I was asked in one of the sessions about outside of this, like in one of the panels about plastic pollution and COVID. And I was asked a similar thing, that banana peels were used to create some masks. I think at that point, the demand was so high that those 500, 600,000 banana peel masks would have meant probably nothing. But again, you can have a discussion on that. And as far as bioplastics concerned, a lot of small grass, waste products from the agriculture, from the food waste, can be used to make those small changes. And if you're not thinking about those, let's say if you're not thinking about plant-based cutlery and plant-based products, how about just switching to steel, the good old steel that our grandparents used to use? Just have more products of steel in the house. That's long lasting, it's cleaner, and it stays with us for a longer amount of time. We just carry it wherever we go. So just making your lives a little less convenient, I think, would be the answer. But you're also right. I mean, I'm not completely brushing off the question. That's also an issue, that the demand cannot be met. But I think a slow shift towards that would really help. Bamboo is the fastest growing plant. Yeah, that's why bamboo is chosen, and that's why bamboo is encouraged. That they grow so fast that it's still better than leaving plastic and microplastic products into the environment. Any other comment? Hassan, someone else had raised their hand. No? So should I just come back to the assignment? Okay, so the assignment last week was about looking at the standards of either effluent from industries and households, from industries, or from your ambient air. Just looking at the standards of Pakistan, comparing it with a standard from elsewhere. So for example, you have a NOx emission for vehicular emission in Pakistan, and it's a number. And then you compare the same number with a number for Canada. So the same parameter and the limit in Pakistan and the environmental limit in Canada or in Germany or in Hungary, whichever country you want to compare with. And in that comparison, you should just be able to see what is the difference. Is it the same values? What do those values mean? I think it was a very simple assignment given to you to understand standards. And when I said identify the gaps, it was just, I think I can explain it now because people are more confused than I meant to confuse them. Is, for example, in the West, they would even tell you what kind of fuels to be used, right? If it's octane something, there would be numbers, there would be more details. So for us, it would just be, this is the amount of NOx that your vehicles should contain. But maybe in the West, they would also have an additional information of what kind of fuels, and how updated the engine should be. So if it's a combustible engine, then I'm sure there are different grades of that or different models of that. If it's an electrical vehicle battery, then I'm sure there are a lot of categories there. So depending on those, you just need to make a comparison, and you're supposed to submit the assignment on the 3rd of November. Hassan.
And the first part of the assignment also asked us to list down the lowest quantities in the NEQS, and it also asked why. Are we supposed to justify that number? Like, why do we have that number?
So for example, it's very stringent for some, like let's say it's very stringent for lead or arsenic. It was just to give you an idea. You can forget that part or you can do it. It was just for you to understand it better. So let's say for lead, it's very conservative both for Pakistan and in another developed country. And why would the lead concentrations be low? Or why would the lead concentrations be expected to be low? Because of its health consequences. So just like a comment or in a third row saying what information has the developed world given about the standard, and then another tab that says because this is the health impact. So not like a big assignment, just a small crisp assignment for you to understand the NEQs or the standards better, because I don't want you to cram them, but I also don't want you to overlook them. I want you to understand them.
Ma'am?
Yes, Nadia.
But ma'am, the first part says that we are supposed to select 10 parameters, either gaseous or liquid in the liquid form. So, but on the other hand, it says take the highest or the lowest value one. So I don't understand why. I mean, are we supposed to choose the highest or the lowest or all the 10 parameters that are asked?
Yeah. Just forget that and forget the highest and the lowest. Just remember that you're taking 10 parameters and see in those 10 parameters for which one of them the limit is more stringent. So for which one of them it's less, and for which one of them it's high. So if it's high for zinc, why is it high for zinc? And if it's low for arsenic, why is it low for arsenic?
Okay, so whole assignment is a comparison between Pakistan and some other country.
Yes.
Okay. Thank you so much.
You're welcome.
Ma'am, I had a question.
Go ahead.
Ma'am, it is about the second part. So while spotting the differences, so do we need to cite the sources from where we have taken the research or any other information material?
If you are, it's up to you. I mean, I do not want it to be very complicated for you. It's up to you. So if you're citing any information, maybe it will strengthen your assignment. Like I said, my sole purpose of giving you that assignment was for you to understand the standards and how standards work without really making you memorize it. And as far as the information, I expected that you would look at the NEQs here and the US EPA standards or the standards for Canada, bring them together, see what the values are, and then see where do we have it low, where do we have it high, and what could be the purpose for that. But also see what additional information their NEQ has or their standards has that our standards don't have. And really for you to understand it, it's going to be a 1-2 pager assignment, very simple, very easy. I thought my course is easy, and this assignment I thought was the easiest assignment that anyone could give you.
Now, ma'am.
Okay, ma'am, thank you.
Ma'am.
Yeah.
Now, as you have modified the question, so can you please update this on LMS?
I can.
Otherwise, we would feel like we are doing something incomplete. I mean,
no. Don't worry. I'll do that.
Oh, okay. So can we leave now?
Yes, you are free from my side. I will not conclude this session because I will let you go home and think about it. And nobody else has questions, comments, right?
Yeah. Thank you so much.
Allah Hafiz, ma'am.
Allah Hafiz, Roshan. Thank you for coming.
Thank you so much for having me, Dr. Fawzia. Thank you. Allah Hafiz.
Allah Hafiz.
Allah Hafiz, ma'am.
Allah Hafiz, Rafi.
Allah Hafiz, Dr. Fawzia.
Hi, Summer. How was your meeting?
Hello. Oh yes, my meeting, it was good. But I think there's